Welcome to this launch status news conference for Space Shuttle Endeavour's STS-134 mission to the International Space Station. Joining us at NASA's Kennedy Space Center this afternoon are two managers who will give us the latest on efforts to prepare Endeavour for its next launch attempt. First, we have Space Shuttle Launch Integration Manager and Mission Management Team Chair Mike Moses.
Good afternoon.
And Shuttle Launch Director Mike Leinbach.
Good afternoon.
We'll start with some opening comments about where we are and then open to questions, sir.
Thanks, Howard. Well, let's see. The team's been working really hard on the troubleshooting plan. We've been getting information updates as they go. It was a pretty good plan that they had, and I'll let Mike go into the details of how they got to where we are today. But the bottom line is that the failure that we have appears to be a power problem, which is in the LCA, the Load Control Assembly box, which is basically a box of switches that we use to control power feeds. So that's an electronic box. So that basically means that the power's not getting out to the heaters that weren't working on launch day, and we need to go in and change out that box. The team had some options in case it was a ground side problem, on the ground, electrically grounded side problem. We could have maybe kind of hot wired our way around and rewired a few things. But this is on the upstream side, so it's the power feed side, and there really are no options other than replacing the failed component, which requires removing the whole box. So that work's going to take us a while. So unfortunately, we're not going to be able to make a launch attempt here in the next few days. I'm here to disappoint everybody by saying I'm not going to tell you what the new launch date is because I have no idea. We have a lot more to evaluate, both the work to do the R&R, the retest that has to be done, how we work all that schedule in. There's the Atlas on the range launching on the 6th right now, so we have to evaluate conflicts with them. And then the mission timelines and the ISS time, we're going to be coming up as we move to the other side of the Atlas. We'd be looking at some potential conflicts with the 25 Soyuz undocking, and we want to make sure we deconflict the right way with that activity. So right now, we're not ready to set a launch date. We're going to need a couple more days. We might have an MMT tomorrow to pick the day. We might go to Tuesday and do that. We'll kind of wait and see when we have enough data to make that decision. But we can tell you pretty much that it's not going to be any earlier than the 8th. That doesn't mean we're going to go launch on the 8th. That just means we know right now the 8th is our next available opening. So we'll kind of start looking at that, but we're really not even setting the schedules today. There's still a whole lot of short-term work that has to be done. In addition to, once the box comes out, we have to go verify circuitry and prove that the box itself was the failure and that there's not some other failure in the ship somewhere that we're getting fooled by. So we still have a lot of work and a lot of off-roads that could take us one way or another, but we're not going to try any earlier than the 8th, and we may or may not be on the 8th itself. So again, don't take that as a launch date, just take that as a target for when we're ready to start talking again about a launch date. So with that, we knew enough that we could send folks home. The crew has departed. Their families are on their way home. All the support teams from other centers around the country have gone home or are in the process of going home. Like I said, we'll then convene as a management team on Monday or Tuesday where we'll start to discuss future options and bring in the whole entire team's impacts with the space station program and then the range and the Atlas team. I talked to them this morning. They're still in really good shape and on schedule. They don't anticipate any hiccups in their flow. But again, obviously, we need to be ready in case they had some problems too, as to how we'd mutually work through range conflicts as we get to the end of that week in May. So about a week from now. So that's the quick and dirty answer for us. A lot of more work to happen. The teams have been doing an amazing job up to this point. And again, one of the things we can tend to not try to make decisions too quickly is this team has shown again and again that given enough time, they can come up with some pretty creative solutions. So right now we have what looks like a boilerplate schedule to go pull this box out in the next day, go retest, put a new box in, and then do a whole bunch of checks, get back into launch count. That looks like it's a pretty aggressive schedule to make the end of next week, but you know, they need more time to go look and see how they can parallel that work up and what really has to be in there. So we need to give them that time before we go set any dates in front of them. So we're going to let them do that. With that, I'll let Mike talk to you a little more about the details of how the team's been working. But again, can't be more proud of how they're responding. We continue to make really good decisions based on the data we have and try not to make any decisions before we actually have data. And we've been doing pretty good with that so far. So we're going to keep on that track. There you go, Mike.
Okay, well, thanks. Let's see, we've had a series of telecons over the last day and a half or so to try to understand this problem a little bit better. And as Mike said, it does lead to a box R&R. So we're in the process of gaining a full platform set in after the orbiter. That's not required for the box itself. That's required for some of the retest. We have to get all the way down to the bottom of the aft compartment for some of the retest. So that access is going into after the orbiter right now. We're also establishing the connection for the orbiter midbody umbilical unit. That's the unit that we use to drain the PRSD cryogenics. We need to offload PRSD for this operation. We also need to disconnect our ordnance. Complete ordnance or partial ordnance, that's still an open question for the team. They'll come to grips with that later this afternoon or this evening. And then we'll power down the ship tomorrow, and that will effectively take us out. It does. It takes us out of launch countdown. And then we'll get into the box removal. We'll check the cold plate under the box, right, to make sure there are no dings as we were pulling the box off. We'll put in the new box, and then we'll get into the retest. The retest is quite lengthy. We've done this once before in the integrated flow, STS-70, I believe it was. And there are 9 different systems we're going to have to retest, so quite lengthy retest. I think we reported the other day 2 full days of retest. We're taking a good hard look at that schedule that was developed many years ago to see if that's still all required, or maybe there's even a bit more. But right now our tentative plan has 2 full days of retest, after which we get back in and connect up ordnance again, get into launch countdown, and it'll be a standard 3-day launch countdown. We'll start over from ground zero, and we'll load PRSD 2 days before count, and then launch 2 days later. So it's a heck of a lot of work ahead of the team. I'm extremely proud of the work we've already done over the weekend to understand this problem. And now that we've essentially pinpointed the problem to inside the load control assembly, we'll get on about our business of taking that guy out and replacing it with a new one. So that's the work in front of us, and the team is ready to execute. The team is upbeat, I'll tell you. A little disappointed, of course, that we couldn't launch, but you know, responding to problems is one of the things we do best around here, and the team always likes a good challenge. I'm sure we're going to be really glad when Endeavour is finally on orbit, but right now the team is upbeat and ready to execute the plan that we've laid out. So with that, we'll be glad to take questions.
Like he said, we'll, when the microphone gets to you, no, I don't know what to go from here. Please wait for the microphone and name, news affiliation, and to whom you'd like to answer your question. And we'll start with the front row. Marcia?
Marcia Dunn, Associated Press. I'm just wondering, what do you think's wrong with the switch box? And is it is it just sort of an illustration of how the shuttles are getting older and perhaps how complicated they are? Could you just sort of put this in a big picture for me?
Yeah, well, we won't know exactly what's wrong with this particular, it's called a hybrid driver. It's essentially a power switch. We won't know for sure until we get that box out and we send it down to our malfunction lab for detailed analysis. But we know the power's not getting through. And so there's a short or an open, something like that inside that box, and we'll go do a complete forensics on it. As far as, you know, the orbiter getting old, no, it's a machine, and occasionally machines break, and this time we had a failure in a switching box, and so no, I mean it's just part of the business. We go to great lengths to test various systems, but this one just failed on us, and so that's where we are.
And these things, in addition to act as switches, they also act as fuses effectively. And so same kind of thing. It doesn't mean that hybrid driver itself was the cause. It could have been the victim, so to speak. So some other circuitry opened up, put a little high spike of current in there, and this guy popped off and did what it was supposed to do. So we really need to wait and get in there and see. But no, you know, this kind of, I don't want to say it happens all the time, but these are typical electronics failures. And nothing in there that indicates anything with age of life or your age of components or anything like that. Nothing to make us suspect that.
How long has this box been working or in there? Do you have any idea how old it is?
Oh gosh, I don't know. I don't think
we
asked that question.
on this particular box. Don't know.
We'll have to get you that.
Hi, Clara Moskowitz with Space.com. And can you give us an idea of how this slip might affect the 135 launch date?
You want to take the rollout part of that one?
Well, let's see. Atlantis is due to roll out of the OPF on the 10th over to the vehicle assembly building and out to the pad on the 20th of this month. And so if we launch by the 8th, that's probably okay. If we're a little bit after that, then it may be a slight impact to Atlantis's rollover and rollout date. The key there is having enough time to turn the launch pad around from one launch to the next rollout to deal with any kind of damage we may have had from the previous launch. Typically, we bookkeep 8 days. I think this allows us 10, something like that. So, you know, it's the kind of thing where it's getting kind of close, but right now we're not worried about it. Right now, on paper, the Atlantis mission looks perfectly fine.
What can you tell us about Congresswoman Giffords? You mentioned that the crew's families were heading home. What would her status be?
See, I don't have any specific details on her particular travel plans. You'd have to contact her staff and office. But from a family perspective, I know we worked the details today with the crew office to tell them that there was no launch attempt that said that there was a need to keep the families in town from a travel perspective. So, they're free to make their own plans to go home. So I can't give you any specifics. Sorry.
Okay. Jay.
Jay Barbary with NBC. Can you think of any scenario, good luck scenario, where you could launch before the 8th?
Yeah, no, that's kind of why we decided. We talked last night. We were kind of still holding some hope that we had some time. When we looked at the need to actually go after the box itself, that kind of set the timeline to say, with that retest required, we could potentially go a little bit earlier than then, but there was no need to try to hold on hope to have Atlas have some problem or go push them to make them come off the range for a schedule that we weren't really sure of yet. So no, that's why we're ready to say we're not going to be going earlier than the 8th, but we're not sure that that's the right date yet either.
Okay. With Bill back, third row.
Bill Harwood, CBS. Two quick questions. For Mike Moses, if I know the 8th isn't a date, it's just no earlier than target, but I'm confused about the 9th. That's not available, is it, as it stands today, because you'd be in dock in the same time Soyuz. So if you went on the 8th, you'd skip a day to the 10th if you didn't get off.
Yeah, so I've learned after 3 years to be careful what I tell you guys. So I could tell you right now, yes, right now we on paper say that's not a good date, but we say that because if we launched on time on the 8th and added the 2 mission extension days that we want to on orbit, we would then be undocking on the same day that the Soyuz 25S undocks. So there's nothing to say that we can decide we'd rather launch on the 9th and not use +2 and only use one of those 2 days, in which case we just deconflicted and the 9th's now a good day to go. We're not thinking that's what we're going to do, but all that thinking was based on before we knew we might be really seriously thinking about launching on that day. So now that we know we're seriously headed into that conflict, we're going to go talk. One of the big things I need to wait till tomorrow to talk to is our Russian counterparts and our station counterparts to find out truly what that does to the timeline. So, yeah, we kind of on paper say the 9th's not a good day, but don't hold us to that. We could easily decide we want to rearrange the mission a little bit and make the 9th a good day.
Thanks. And for Mike Leinbach, could you just give us days when the box comes out, when you expect to have the new one out? I assume it comes out tomorrow, the new one goes in Tuesday or something, or maybe tomorrow. And could you give us a little detail on why the retest is so complicated with those 9 systems, what sort of things you have to do to go through that process? Help us explain why it takes 2 days. Thanks.
Sure. Well, the box on paper right now, the box will come out tomorrow. Again, we'll send it down to our malfunction lab for detailed inspection. And the new box goes in on Tuesday. And, of course, as we work through this tentative plan that we have in front of us here, work execution is going to dictate the exact timelines, but that's generally it. And then after that, we get into the retest Tuesday night, Wednesday, that kind of time frame, and it's going to be a full 2 days of retest. And I can read you the various systems. I wrote them down so I wouldn't forget any. Auxiliary power units, environmental control and life support, electric power distribution, booster electric, hydraulics and our water spray boilers, main propulsion systems, orbital maneuvering systems, space shuttle main engines, and orbiter flight controls. And any time you break a connection to a box like this, you essentially invalidate all the testing we did up to that point. You could take the tact of saying, well, all you're doing is replacing the box, everything downstream of that box should be fine. Well, that's true, but our requirements are, the way we do business is whenever we break a connection, we go back and retest it. That's just a prudent thing to do and the way our requirements are set. And so we have to retest every one of those 9 systems. The details within those systems, you could probably write a thesis on how many individual tests there are within those 9 systems, and that's why it takes so long.
Okay. Robert, right next to him.
Hi, Robert Perlman with CollectSpace.com. I think for Mike Moses, given that you have the time now, and if it's necessary or not, I don't know, are you going to have any teams look at the ohms pod, the right ohms pod, in terms of the slight pressure differential that was seen during the count?
Yeah, no, I don't think there's any plans to do that. Really, what that was a creep in the regulator, so leakage that goes through the regulator down into the downstream components. We had already known about that condition pre-flight. It was really just a confluence of events of the time it sat in lockup. It creeped and bit flipped up just enough to trip the limit. The action we took to equalize the pressure seemed fine. I don't think there's any plans to do to do anything other than maybe some more data reviews to make sure there wasn't anything else going on there. But no targets to go after anything in the OHM system.
Todd Halverson, Florida Today, with one for each Mike. For Mike Moses, could you just remind us why you don't like to do 2 undocking operations on the same day? And for Mike Leinbach, could you kind of give us a little information on the work environment the technicians will have in front of them in the aft compartment? And it's pretty cramped, as I recall. And what would you do to make sure you do no harm?
Let's see, on the undocking, really it comes down to crew workload and shifting, especially when we're dealing with a Russian vehicle and a shuttle vehicle. The sleep shifts required for each of those are going to be pretty drastically different. So, the Russians are going to, the Soyuz crew is going to be undocking and within a day coming back in to deorbit and land. So they need to be on the right sleep shift so that they're well rested and able to execute that event. Whereas our shuttle crew is on a sleep shift that set them up for their launch and is slowly phasing to protect them for their landing, which I think, I haven't looked at the details, but based on where we were, knowing that we're delaying, that's going to start to head out of phase from each other. And so we're probably going to have a decent little sleep shift for the crew, which could be a problem just in general for us. But so we basically, on a crew work day, on that given day, having both crews trying to work to 2 separate work schedules wouldn't really work very well. A lot of activities have to happen both for a shuttle undocking and a Soyuz undocking, and to try to do them on the same day would be quite a challenge.
Well, see, Todd, on the question about the work in the aft, the box itself is in avionics bay number 5, which is just inside the door. So the work itself to replace the box is really quite easy, relatively speaking, and access is good. We'd put in the entry-level platforms and maybe one set below there. But then we have to put in the full set in order to get all the retests, to get to the various end items that we need to retest. And from that perspective, it's the same as closing out the aft every time. I mean, we'll have an engineer, we'll have a technician, a quality inspector, both NASA and USA if necessary for a particular function. So to me, it's standard work. It's just unfortunate it happened to us in Countdown. It's getting all this attention. We do this stuff all the time. I say all the time. Whenever we have a failure, we do it. And so the work itself is really not that bad.
Okay, back row.
Carrie Feibel, Houston Public Radio. On behalf of my audience, which is very general and doesn't speak acronym, can you just describe normal function, this box, what it does downstream? Does it provide power for all those systems you need to retest, or just can you, in simple terms, lay out why this is a necessary?
Yeah, so it's you could think of it as in your house wiring. It's not the primary fuse box on the outside of your house, but it would be the equivalent of if you had, like in your garage or in your laundry room, a breakout box that kind of a sub panel. So it's effectively one of our sub panels that's taking the main power. We call this a load control assembly, and it's an aft load control assembly. There's 3 of them in the aft compartment that take our 3 main orbiter buses and switch power to all the functions. One good way to think about how many systems this touches, most of the systems in the aft compartment are redundant, and most of them are at least in terms of critical flight control functions, have 2 levels of redundancy on them. So that means they have multiple power feeds going to them, and we're about to disconnect one of those power feeds. To verify that we reconnected that power feed correctly, we have to go test that item again to make sure it's now receiving power from the source. We're basically going to disconnect a wire at the fuse box, and we can't test right there. We have to go down to the light at the other end of the wire and make sure that light comes back on again. So if that helps in a simplified way, it's effectively a sub-panel fuse box. It's a power switching. We call it a power switching because we have the ability in the cockpit to turn the power, and if we lost the primary power, we could switch it over to alternate power. So we use low voltage power in this box to switch those power feeds around. And so that's why we call it a switching box, but it's effectively a fuse box.
The power is not just powering the hydraulics, the mechanicals that we were talking about on Friday. It's more than that?
Correct, yeah. So the APU heaters are one of probably 70 or 80 things that go through this box. I know some of the systems on there are ohms valve. So in the ohm system, some of the valve power goes through this box. And so we're about to go take that down. You need to go verify that that valve still has proper power for functionality. There's reaction control drivers in the RCS system, which provide power and command to the jets to fire. There's main engine commands that go through there. So a lot of things besides just this APU. In fact, this APU is probably just one of a tiny little thing that goes through there. We know how to test the APU again now.
Donna Linewan from USA Today. Do you have any sense about when the astronauts will come back and what they're going to be doing in the meantime?
Let's see. In the meantime, well, let me start with the first one. Like Mike said, we'd reset and effectively start launch countdown over again. So when we do pick a new launch date in the next couple days, all the schedules will reset and the crew will come down at the normal time, 4 or 5 days. I actually don't remember exactly when they do come down, but they'll come down at the normal time before a launch period. So we don't plan to be in this kind of what if, we're not really sure when we're going to launch and sneak the crew in and suddenly go launch. It'll be a pretty cut and dry, this is our new target date, go reset all your schedules and march to that date. We're just not ready to make that decision today. In the meantime, the crew's going to basically kind of go back into training. They will stay in quarantine. I think if we launch on the 8th, they could come out of quarantine today but have to go right back in tomorrow. So there's no real point to that. So they'll stay in quarantine back in Houston. I know that the teams are working to set up some ascent sim training probably on Tuesday or Wednesday, so they'll start some refresher training. Whenever we go for about a week, it's good to let them have a chance to get back in the simulator and work through the normal processes. And they'll probably have some standalone training. A lot of what they do is kind of, we call it free time, but the crews are unbelievably dedicated. They don't do anything in their free time other than study their checklists and practice their procedures. So I don't think they're going to go jump in the pool and do any EVA training, but I bet you they dry run through the timelines at their desk and review what they're supposed to be doing, rehearse. They put their time in to be ready to go, that's for sure.
We'll go to the side and start over here.
Hi, Ken Kramer for Spaceflight Magazine. For Mike Leinbach, I think. Can you tell us a little bit about the testing you did on this unit before the launch to ensure that it was good to go? And on STS-70, I believe, was it exactly the same problem that you found, or was it a different problem within that box? Thank you.
Well, the testing leading up to the countdown, as Mike described the other day, a lot of the times what we take credit for is the on-orbit success or failure of a system. And so this particular box, not every function was tested in the OPF. We do take credit for on-orbit operations. But everything seemed to be working just fine. And how the failure occurred, we just don't know yet. And what was the other part? I'm sorry?
On STS-70, you said you swapped this box out before. I wonder if the failure in that box is the same as what you suspect now, or was it a different failure?
Did we get that
don't
data?
know, yeah.
I don't think we got that level of detail.
Yeah, we haven't got that.
We know we took the box out, and therefore that creates the full retest of all those systems I mentioned. What the particular failure was back then, I don't remember. We'll have to get that for you. Chances are it was not this particular failure, because there are dozens and dozens and dozens of functions that go through this box.
And if this replacement box fails, do you have another one after that? Thanks.
Boy, if the replacement fails, no, we're not going that way. The replacement's going to be great.
And that is, the team has built into the timeline, once we do have the box out, retesting and checking of the circuitry to verify that box was the failed component. So, capacitance testing on the upstream and downstream components. We kind of already verified heater functionality, but they'll probably go in with breakout boxes and double check all that to ensure that there is no downstream wiring damage that might have been a cause to cause this box to go, so that we don't put another one in there and blow it too. So that'll be part of the normal test planning before we go put a new box in place. Definitely be doing that.
Sentinel from Mike Moses. I just want to get a little bit of a clarification on the Soyuz undocking complication. Since 134 can have 14, 15, or 16 days, are you essentially trying to preserve a 3-day window on the other end here?
Not necessarily. We're basically trying to preserve those 2 extension days. We know ahead of time were very valuable for the station in order to have get-ahead tasks. So we knew pre-flight we wanted to add those 2 days. you could almost say we're 99% ready to call this a 16-day mission rather than a 14-day mission. But we didn't want to commit to them just yet until we got in orbit and evaluated other conditions, like how the crew did, how they're doing on rendezvous, how they're adapting to being in space, make sure there's no sleep shift issues. The original plan was it was going to be a piece of cake sleep shift, so adding those +2 were going to be a pretty no-brainer. We'll sit down and look at all the new math and see where we're at. The act of staying up 2 more days now might be a little more stress on the crew if they are having to do a big sleep shift, and we might decide that that's not the right thing to do anymore, which would then tell us we don't need to cover so many days of a launch window, and we could drop a day off that mission. So yeah, it's kind of what you said, but it's a few more factors than that too. One of the reasons why we need a little more time to evaluate exactly what the right decision is.
Right now is the conflict with the 16th day?
Yes. Yeah, well, right now the conflict of why we wouldn't launch May 9th is because on the 16th day that would be undocking. Actually, that's not the 16th day. It's on the second day of docked operations, second additional day of docked operations.
But, okay, but it would affect
the consequence of having a 16-day long mission
okay,
would put the undockings on the same day. Yeah. I know it's confusing without a calendar. I don't have one either.
Paola Catapano, CERN and RAI, how far can you push this mission not to forfeit the next one?
Well, as Mike said, we know that the 8th, 9th, 10th is probably about the same, not too much of an impact. Beyond that, we'll have to look pretty close. So we're getting very close to being an impact to the next mission. We're not quite there yet, but that's one of the things the teams will take a close look at. One of the consequences of of us coming to the end of the program is we no longer have multiple teams able to do the jobs. We're down on our resources and our staffing, so we need to make sure we know what this launch schedule is, and then we'll let the next team take a look at what they need resource-wise and make sure we don't have to move that launch date to avoid some conflicts. Really, I think what we're going to find is the pad turnaround that Mike talked about is really going to be our driver of once we launch this vehicle, go out, assess the damage to the pad, how long it'll take to repair, and be ready to receive the next mission. On paper right now, it looks like we're okay. But if we go too much past the 9th or the 10th, then we might need to add a couple extra days. So I don't want to tell you no impact, but I don't want to tell you definite impact. It's getting close.
Zane Schock from the Houston Chronicle. Just wanted to know about the quarantine. Can you explain to us again why astronauts have to be on quarantine and where are they going to be quarantined in Houston? Also, I understand they're allowed, I think, 1 visitor a day for a certain amount of hours. Does that visitor have to come to the quarantine area, or are there exceptions being made for certain astronauts, like Commander Mark Kelly?
Yeah, we lock them in a box and we don't let anybody ever see them again.
That's going to get reported,
Yeah, the quarantine rules are pretty straightforward. I don't remember the exact number of days before a mission, but the purpose is to basically stay away from any contagious illnesses that would then take a few days to show up and manifest. And so the quarantine basically is the crew reports to a quarantine facility that's on site at the Johnson Space Center, astronaut crew quarters. It's a pretty nice building, conference room facilities, training facilities, a gym, and sleeping quarters. And then they have contact a lot more than just one person for an hour a day. There's a whole list of folks who are on the approved contact list as long as you've passed your physical and are cleared with what we used to call a primary contact physical. I think we've changed the name of it recently, but it's effectively, if you're in primary contact with the crew, you also have to show you're in good health. Really, the biggest restriction is in terms of young children. Those are the ones that really we have trouble for those of us who have very young children. They bring home all kinds of nasty bugs, and you get sick on a short notice. You can tell I'm coughing. I am currently not allowed on primary contact with the crew by choice, if nothing else. But it's that kind of thing. So they'll go back into quarantine at the crew facility. They'll be able to visit with family members who are cleared and through their physical process. They'll start meeting with all their trainers and all their flight directors and the training crews, and they'll get back in and do their job. It'll be a lot like they were just a couple days before they came down here. Not a lot of difference for them. Yeah, they'll be at Johnson Space Center. No, they'll stay in the crew quarters. But they're not restricted and locked in the building like I was joking at the beginning. They'll leave and they'll go over to the trainers and they'll run in the training facility. If they needed to go out to the NBL, they could. So they're not locked down. They just don't go home and sleep at night in their own bed at home.
Anna Leahy, Lofty Ambitions, and Chapman Magazine. One more clarification on the crew. When you're working a delay, how long does the delay have to, how long do you have to know the delay is going to be before you send the crew home? Does it have to be at least 5 days? Because that's what they would normally spend here.
Yeah, that factors into it. Really, it's kind of more just of a logistics. If we knew that we'd be picking up a launch day such that they'd go home, turn back around, and have to fly back here the next day, we'd probably give them the choice to do that if they wanted to. It's not like they can go back and repack their suitcase and do a lot of other things, so there's not a lot of drive for them to return home on a short trip. But then again, it is a chance to go back to your home environment and get a little more comfort, a little more contact. You're not stuck here at the Kennedy Space Center. You're at least stuck at the Johnson Space Center, which is a little closer to your home. But it really comes down to a trade, and the crew office, the crew management office, and the program talks about the likelihood. We had those conversations this morning, and I let them know pretty clearly that we weren't going to be looking at a Thursday, Friday launch attempt, and there was no need to keep the guys here. They could head home, and we'll bring them back when we're ready.
Mark Boucher, Space Ref for Mike Moses. Are there any dates between the 8th and the 15th that you have ruled out?
Not specifically, no. Those all look pretty good to us.
And a follow-up question for Mike Leinbach. Have you ever had a failure with the hybrid drivers before?
I don't know the answer to that. I'll have to get you that data. Did we hear that in any of our telecoms last night?
Yeah, I know failure history. We've definitely had hybrid driver failures before. Whether it's this specific hybrid
particular
driver,
one,
I don't know.
Gene McCulka with Talking Space. Could you give us an idea on how big the LCA is? Is it bigger than a bread box or something like that? What?
It's 40 to 50 pounds. It's probably on this sort of scale, maybe a little bit bigger. And to get it into the avionics bay is a little bit of a trick because you kind of wiggle it up there and then attach it. And so we have a system of rails that we actually use to guide the box in place to help the technicians as they're bolting it in. And so we have to put the rail set in as well, and that's just sort of a safety precaution. I mean, the guys probably could muscle it into place, but it's a heck of a lot easier with that rail. So it's 40 to 50 pounds, probably 48, something like that, and little tricky to get in the avionics bay.
Okay. Oh, I guess actually this side then. I guess we have Ken as a follow-up. Sorry.
Hi, Ken Kramer again for Spaceflight Magazine. For either Mike, I'm not sure. These hydrazine fuel lines, can you tell me how thick they are and what kind of pressure they can withstand, please?
Oh, God, I don't know that one off the top of my head. Yeah, I don't know what an APU fuel line. I could speculate, but I'd probably be wrong.
I don't know either, Ken. I'm sorry.
We'll get you that.
Because you're right. The concern is if it thaws and expands, that the lines could
Right,
rupture.
so we have a lot of testing, and we've done that at our White Sands test facility in New Mexico, a whole bunch of testing to show that the lines, we can basically withstand a single freeze-thaw cycle. But beyond that, you then kind of really start to worry about the integrity of the system. We've shown in that testing that the plug of hydrazine ice that would form would kind of move up and down the line, so that's not really the problem. But there's a lot of valves and plumbing and piping, and if you were in one of those regions where you had an ice ball formation, you'd worry about extra stress in that region, which is hard to model and test. And therefore, we tried our very best, and that's why this rule allows us, or does not allow us, to launch with a failed heater. We want to make sure we have good integrity of those systems so we don't ever have to get into a freezing concern.
Okay.
Doug Deco, Knox Magazine. Since you introduced that part of the functionality of the LCA is as a fusing system, doesn't that allow for the possibility that something upstream of that fuse is malfunctioning? And if so, what would concern you the most?
Yeah, most definitely. We've effectively kind of cleared the wiring outside the box by doing the thermostat response tests and the measurements of the current there. They're going to go back and do that again with a different set of equipment once the box is out. But there's a lot of internal components inside that LCA that takes the power from the connectors down to the right hybrid driver over to the common ground hybrid drivers. There's a lot of a wiring path in there that could be the problem. A little piece of debris or something like that, a blown piece of electronics gear could have been what caused this. Just a solder connection that came open really could be the problem. And so we'll take that box out, and then we'll confirm that the failure's inside that box, and then that'll give us the confidence that we know it might not be the hybrid driver itself is why the problem happened, but the problem's also inside the box as well, if that makes sense.
Okay, well, looking around, any last questions that need answering now? Okay, not seeing any hands up. We do have some new video of some of the activities going on at the pad this morning. It's not any of course, as you've heard them say, nothing about the actual change-out work since that hasn't happened yet, but at least is some fresh video from today. So we'll be playing that after the briefing. Of course, to follow along online, go to www.nasa.gov/shuttle. I'll tell you about any of the mission preps and the quarantine crew. And thanks for joining us.
Everybody's good something. For that. There. You guys probably had a busy day on Friday.